Chapter 8, Baryonic Acoustic Oscillations. BAO is a preposterous name for a preposterous phenomenon. And yet, I don't want that to sound like a condemnation of the BAO proposal. It's a fascinating result worthy of investigation. But the way BAO is explained in the literature is appalling. I encountered the term several years ago, but I didn't fully grasp it until earlier this year. Part of the blame goes to me, as my initial effort was minimal, but the literature is definitely subpar. Here's the opening paragraph of the Wikipedia article for BAO. In cosmology, baryonic acoustic oscillations are fluctuations in the density of the visible baryonic matter of the universe, caused by acoustic density waves in the primordial plasma of the early universe. In the same way that supernovae provide a standard candle for astronomical observations, BAO matter clusters provides a standard ruler for the length scale in cosmology. The length of this standard ruler is given by the maximum distance the acoustic waves could travel in the primordial plasma before the plasma cooled to the point where it became neutral atoms, which stopped the expansion of the plasma density waves, freezing them into space. The length of this standard ruler, approximately 490 million light years today, can be measured by looking at the large-scale structure of the matter using astronomical surveys. BAO measurements help cosmologists understand more about the nature of dark energy, which causes the accelerating expansion of the universe by constraining cosmological parameters. As you can see, the framing of BAO is constructed in a way that requires the Big Bang. In reality, BAO is a statistical artifact that can be observed when the separation distances of all galaxies are taken into account. It appears as a small but statistically relevant bump in the occurrence of a specific separation distance. In other words, if you consider the separation distances of all galaxies, i.e., the distance between any two arbitrarily chosen galaxies, you will find that 150 megaparsecs occurs slightly more than any other scale. This scale can be recovered through the proposals outlined in the horizon conditions we presented in Chapter 4. In short, the thermal bath of radiation provided by the Hawking radiation at the horizon is enough to pass the recombination threshold for the preferred BAO scale. The scale manifests as an increase in separation distances because there is a limit to how fast sound waves can travel through the thermal bath created from the horizon. In one coordinate system, the length is 0.134 megaparsecs, but it's only visible when observed from distances relative to the horizon, which makes it manifest as 147 megaparsecs. It's like an additional horizon that gets geometrically magnified. The minimum background model is characterized by the following spacetime metric: density profile and mass function. Now, from here on out, these are just equations. I show how the BAO scale can be recovered in my model. And we do this through the Tolman temperature equation. And so if you want to look through these, I'm going to let them play out. But that's the rest of this chapter.